Hi, I'm Charles Dixon, and I'm a member of the SDK team at Couchbase. Today, with my colleague Michael Nushell, who is also a member of the SDK team, we will be demoing a new tool, Couchbase Shell. Couchbase Shell is a new way of interacting with the server via the command line. Today, we're going to do a demo, and then Michael will go into a bit more detail about things like the foundation of the shell and the motivation, and go into a bit more depth. So let's jump straight into the demo. The first thing that you notice when you run Couchbase Shell is that we have a custom prompt. And what this prompt shows us is the current user that we're using, the current cluster that we're connected to, and the current bucket that we're using as well. So let's take a look at our environment. We'll have a look at what clusters are available to us. We have 3 clusters available. We have a prod default, a prod analytics, and a local cluster. We can see the current username that we're using to authenticate against each of these clusters, whether or not we're using TLS, and whether or not it's the active cluster. What the active cluster tells us is that when we run any commands, this is the cluster that the commands will be run against. So if we run the bucket command, we can see that these are all the buckets that are on the local cluster. So here we can see the names of them, what type of bucket they are, how many replicas are configured, and then the quota. So if we want to have a look at what nodes are available, we can do that with nodes. And now we can see the host name, kind of the status, what services are available, and then a bit more information as well, which is great. But we might want to see all of the nodes on all of the clusters. Well, we can do that with the clusters flag, and that accepts a regular expression, so we can match against all of our clusters, and there we have it, all of our nodes that are on all of our clusters. As this is a regular expression, we can also do things like partial matches against names. But there's other ways to filter out these clusters. Nushell provides us with commands such as where. So we can do where version is like 6.6.0. And there we go. We've filtered out the local cluster because that's using 6.5.1. So if we want to delve a bit more into this status, we can see all the nodes are healthy. But let's have a look at what all the services are looking like. So we'll ping all of our clusters and see what things look like. Well, things mostly look okay, but it looks like for some reason key value on all of our clusters needs a bit of attention. They're replying a little bit slow, so we'd need to look into that. As well as ping, we also got the clusters help command. And what this does is gives us a few recommendations about how we should set our clusters up. So we've got a handful of checks, what bucket they're against, what cluster they're against, what we expect them to be, and then what they are. So here we can see that on our analytics cluster, our auto failover enabled should be enabled, but it's not. And then we have a suggestion of how to fix that, which is just enable auto failover. So all this is great and everything, but we've only got it in the shell. We might want to save some of this data for historical use. Well, Couchbase Shell, Nushell, exposes this to command. This can be used to convert any of our table outputs into another format. So if we run the nodes, all of our clusters, and then we do to.csv, there we go. We now have this in CSV format, which once again is all well and good, but it's only in the shell. We can also export it directly to a file, and Nushell will detect that we're using the CSV extension, and then we don't have to do any manual parsing with to.csv. It'll do it for us, so long as we use the same command. So then we can see, there we go, we now have a file with all of our nodes in it that we can use for historical use or something like that. Before we continue, we'll take a look at what our configuration looks like. So here we can see that we have our 3 clusters, and in each cluster it contains host names, which are the addresses for which to connect to that cluster, the bucket, which by default when we connect to the cluster, that's the bucket we will be connected to, and then also the credentials for connecting. These credentials can be moved out of the config file into a separate credentials file, which means that we can then put our config file into source control without leaking any credentials. So let's move on to actually working with some data. To begin with, we'll look at what we're actually connected to. So use tells us the cluster and the bucket. We could do use cluster prod default, and it'll change. And then we can see that our prompt has also changed to reflect that. But we just want to use the local cluster for now. So we'll move back to that. Key value operations are all underneath the doc command. If we run that, we can see that we have some CRUD commands available to us. And to begin with, let's import some data. We have in this directory a subset of the airports from the travel sample. And if we take a look at one of these, and we can see what they look like. So this is what it looks like. But this won't actually work with the docker-upsert command. Docker-upsert expects 2 columns. It expects the ID column and then a content column. The names of these columns can be adjusted, but it does expect just the 2. So we need to do a bit of work to get the data into the format that we expect. To do this, we can use the map command. And what this will do is it will create an ID column and a content column. The ID will be airport and then our ID, and the content will be all of the columns. So we can then see that this is what it'll look like. And the content column will become our document body. In order to actually upsert that, all we then have to do is docker upsert. And there we go. We now have some data in Couchbase Server. But that's all well and good for one document. What if we want to do it for all of our documents that are in that directory? Well, we can do that too. It's very similar to the previous command, but we've added a open.it.name, which tells Nushell to go through each file and do it the same thing for each. And if we do that, we then see we uploaded all 10 of them. And just to prove that that actually worked, we can do docker airport 3749. And there we go. We've just fetched the document from Couchbase. Now, if we want to see what's actually in this content, Nushell exposes this get command, which drills into a column, so we can see it that way. Or if we want to keep the cas there, we can use the flatten flag, which will then bring that content column into the top level for us. So we've managed to import from a JSON file there, but what if we want to import from a CSV file? Well, here we have 5 airports in a CSV file, and importing these is quite similar to the JSON, but slightly different. Here we can see that we're using each, and the reason why we're using each is because rather than them being multiple files, we've loaded them all in at once, so we need to iterate over each row. And if we run that, we can see once again we've managed to upsert our data. But what if you don't have any data? You just want to do some testing, or you just want to play with Couchbase? Well, you can do that too. There's the fake command. And what fake does is, given a template, it creates some data. So this is what our template looks like. We have an ID column, and a content column. And this is what will be in our document body. So if we actually use this, we tell the fake command which template to use, and it will generate us some data. Now, if we look at what this looks like, we can see that this is what will be in our document body. So if we go ahead and create 5 rows, type them into the docker upsert command, there we go. We've now populated Couchbase with some fake data. Okay, so now we might want to actually export the data from Couchbase. Well, that's pretty easy. We do .get of our airport again, and then all we have to do is save our doc as a JSON file. And there we go. If we then have a look at our JSON, we can see that we've exported it. And to do it for CSV, much the same. That's all we have to do. And there we have it. There's our document as a CSV file. Let's move on to taking a look at some queries. We run query. We can see that we can query with a statement directly, or we can also use advise and indexes. So let's run a query. And there we have it. We've selected 5 of our airports from our travel sample dataset. Great. Let's say we wanted to export that. It's pretty similar to what we did before. We just run the query and then save airports. Then if we take a look at our airports, well, there we go. We've exported it. Once again, exact same thing with JSON. Save it as a JSON file. And there we go. We've managed to export all of our query data as a JSON file. We can also take a look at what indexes we have and what sort of state they're in. So here we can see the names, bucket they belong to, the state, type they are, and whether or not it's a primary index. As well as that, we also have access to the query advise command. And here we can see that we don't actually have any recommendations at the moment, but if we did, they would appear here. As well as query, we can also run analytics commands. And similar to query, we've got access to data sets, data verses, indexes, as well as being able to run statements. If we run a statement, we first need to create it. Well, we can do that from here as well. We create data set airports on default airport. And that will create us our data set. Okay, so if we keep going, then next we can see that we can run things like users. And then we can see that we can get the users, roles, upsert. We can do things like that. As well as that, we can run search and a whole load of other commands that are available to us. And with that, I will hand it over to Michael.
Thank you very much, Charlie. That was a great demo, even though the demo gods went as good to us at the very end. Still a very good introduction. Thank you very much. So I'll take over and share my screen here. Okay, so now that we've seen how it works in action, I think it probably makes sense to take a step back and talk through why we did Couchbase Shell in the first place, what motivated us to build it, and also what did we choose as a foundation, right? We didn't want to reinvent the wheel, but rather, how they call it, stand on the shoulder of giants and build it on top of a new framework called Nushell that is under active development and takes the paradigms from current shells and pushes them forward basically into a new era. So what was the motivation behind building Couchbase Shell? So as you probably know, if you've used Couchbase for some time, Couchbase provides you a couple ways to interact with it, right? So we have the UI that allows you to interact with a browser, and we have a couple of command line tools like Couchbase CLI that allows you to orchestrate certain operations like adding nodes, removing nodes, and then we have CBQ, which allows you to run N1QL queries and analytics queries. So there are many different tools, especially on the command line, that you can use. But one feedback we got from users and customers is that there is no single tool that gives you very easy access to your cluster. And as tools also change across cluster versions, it would be great if there is one tool that can handle all of them, especially now that we launched Couchbase Cloud, our DBaaS service. It would be great if that tool could also work with that cloud offering. So one of our main motivations was we wanted to set out to build a CLI tool that is both for developers and operators, and both for newcomers and power users, right? So as you've seen, what Charlie showed you is that like you launch a shell with a basic configuration, and you can read data, you can write data, you can figure out how are my nodes doing, how is my cluster doing, do I have the right indexes set, right? Everything that you could also do with other tools, but very easily accessible in one tool. And on top of the basic functionality, with all the tools that Nushell, which we'll talk about in a second, provides you, you can combine different commands and have a data. It's pretty much like a data analysis pipeline of sorts, right? Because you can get your structured data, and then you can transform it, you can enrich it, you can load from JSON, you can save it as JSON. You can even load from a SQLite file and insert it into Couchbase if you want, right? So there are so many different ways that you can use Couchbase Shell to interact with your data. And another motivation was, as I mentioned, consolidate functionality from existing tools into one tool, right? So that you have one central place, going batteries included. You launch one binary and you're good to go. So with that motivation, what are the requirements that we set on ourselves to build that tool? So the first one is it has to be cross-platform, right? So it needs to work across Linux, Mac, and Windows, and it should give you the same experience across all those operating systems, aside from, of course, like path changes and so forth that you would expect when you switch from Mac and Linux to Windows, for example. It should work across clusters, which means on the one hand, it should work across Couchbase Server versions, but it should also work with Couchbase Cloud. So that one tool for all different kinds of Couchbase clusters. It should come batteries included, so there is one binary, and you can use that one binary and just start out, right? You don't need to install separate libraries, you don't need to install all kinds of dependencies. Download, run, you're good to go. And as I mentioned before, because we want to have additional functionality for our power users, we want to make sure that you can have, basically you can build your own ETL pipeline in the shell if you want it and perform transformations on it. It should be very easy to import and export from different data formats. Also, one thing that Charlie showed you, right? Importing from CSV, exporting to JSON, and there are many other formats available. You can do that for XML, SQLite databases, so many different formats. And I think that the last point on this list here, in my opinion, is maybe the most important one. We want to evolve the tool quickly, right? So we really want to, and what you've seen there is basically is the foundation, right? So that's the starting point. It's not the end of the finished tool, right? So we want to give the tool to you, and then we want to get your feedback that evolve the tool quickly, rapidly, based on your changes, and make the tool better every week, every month, and also release on a regular basis. So I talked a little bit about Nushell, but what is Nushell? So Couchbase Shell builds on top of a project or library called Nushell, which is a shell on its own. But because the way it's written, we can actually use it as a library and build our own binary on top and ship our custom commands in addition to the commands that are available in Nushell already. So if we take a step back, I assume you're familiar with the Unix pipe semantics, right? So if you're running in a traditional shell like Bash, If you run a command called cat, and you load a file, and then you can use the pipe operator to move data from one command, basically the output from one command, and move it into the next command as an input. So you can transform your data. But one of the insights, one of the critical pieces that the Nushell team found out is that the issue is it's unstructured, right? So the input into the grep command here in this case is just arbitrary text, which is great if you're just searching for a string. But once it comes to sorting, filtering, advanced capabilities that actually need to work on structure to be easily usable is missing, right? So this is why Nushell took that a step forward. So imagine one of the commands that Charlie showed you is the nodes command, which allows you to list all the nodes in a cluster or across multiple clusters. And then you want to sort all the nodes by the amount of memory that each node has free. If you're doing that on the command line, it's probably pretty challenging, right? Like you need to do a lot of fiddling around with output of one data and then maybe do some tab, like export it into a CSV or split it up by tabs and then look at what is the right column. So it's definitely not basically two commands, right? But because Nushell understands the structure of the data, all we need to do is we can say, okay, we list all the nodes, which is a Couchbase command, and then we pipe that into the sort by command, which is a Nushell command, but because it understands the structure, it can sort our output data based on a column. So how does that look like? So when we run the nodes command, we get the cluster name, the host names, the status, the services, everything you've seen in the demo. And then we piped it into the sort by command and sort by memory free, which is the last column here in the screenshot. You can see that suddenly it's sorted by the amount of free memory. And as you can imagine, there are many more powerful commands available as part of the Nushell ecosystem that really allow you to take your data in a structured manner and then work with it, transform it, merge it with other operations and so forth. So if you go to nushell.sh and you look at the main motivation of Nushell, this is what it says. So the goal of this project is to take the Unix philosophy of shells, where pipes connect simple commands together, and bring it to the modern style of development. And one thing they don't mention, but if you hear that the Nushell maintainers talk about it, they want to make it fun, right? So they really want to make it easy and fun to work with a shell and give you advanced tooling, but still make it look simple, right? And here is fun, right? So I tried to come up with a command, and this is aligned with one of the more complex examples that you find in the Nushell documentation. But so to give a little bit of an idea what you can do with it is, so Nushell can also run external commands, right? So it runs a git command, git log, and then it prints it in a pretty format, which is unstructured, right? If you call out to an external command, of course, you just get a text block, right? But then we can use the lines command in Nushell that splits up the raw data by lines. So then basically we have one table with one row per line output from git log. And then we split each line into columns, right? And we give those column names. So in this case, we name it SHA1, committer, descending, merged, add, and so forth. And then we pipe that into the Nushell histogram command that creates a histogram out of the committer and merger columns. Then we sort by the mergers, we reverse it to get us the one with the most mergers on top. And then we list the first 10, right? And if you put that into a system like Apache Spark, you would say, okay, I did an awesome ETL pipeline here, right? Which takes data, transforms it, outputs it. But here we did it in like one line of a shell, which is, in my opinion, is an amazing capability. And it really gives you tooling in your hands to really work with your data. So we talked about tables a lot so far. So what are tables in Nushell? The tables are the primary way to deal with structured data. And tables are a very natural concept because most of us, I guess, who are listening and working with Couchbase and databases, they have used relational databases in the past, right? So the analogy there is in your head, it's like a relational table of sorts, right? Where you have columns and you have rows. The crucial difference is the data stream doesn't have to be exactly the same number of columns, right? So you can have in your data stream, you can have data that has columns, that doesn't have columns, and then Nushell will adapt to that and print different tables with a different structure, which very well aligns with the Couchbase concept where our documents have an implicit structure, but they don't have to be the same across the bucket, right? So as you'll see, when working with data combined with Couchbase, let's say you do a nickel query and not all of the rows that come back are exactly the same, Nushell will automatically account for that. And because tables have structure and column names, you can use commands like from, so from CSV, from JSON, which will infer the structure from the original format. But there are also commands available that allow you to create those tables manually. And the table is everywhere, right? So Nushell gives you an ls command, which very much like in Bash or other shells lists the files in a directory. Here in this case, it returns you a table, and then you can use the same operators like sort by first to work with structured data from your file system, right? And you can filter tables, you can transform them, you can export them, you can merge them with other commands. As I mentioned before, so here's an example of how to import data. So if we open a txt file, Nushell can't infer which type it is because it doesn't have an ending like JSON or CSV. Now, in this case, we open the file, we get our raw text data back, and then again, we use the lines command to split up by lines, and then we use the split command to split up each column by the pipe operator. And then we can use the trim command to remove the excess white space, right? So we'll end up with 3 columns. And those 3 columns reflect our text file format. So even if you have a custom file format that Nushell doesn't understand, it is very easy to transform it into an actual structure. One example where Nushell understands the file format is if you run the open command with like a toml file. Toml is a very popular config file format that we also use in CB Shell for configuration. And if you open a toml file, Nushell will automatically understand the format, and then you can call into your toml file and extract certain pieces of data. Here in this case, we open the toml file of our Couchbase Rust SDK, which, by the way, if you're using Rust language, we have a community supported Rust SDK available on Couchbase Labs, and we are actively working on it. It is also used inside Couchbase Shell, and if you want to contribute or you have questions, of course, you can reach us there as well. On the exporting side, very similar to importing, you can export into various file formats, right? So you can export to JSON, CSV, TSV, other file formats that Charlie showed you. Very easy to work with and really is the end of your ETL pipeline if you want. So where can you learn more about Nushell? And I really only touched the surface. There are so many more things to learn, so many great commands. It is under active development. So if you're curious, go to nushell.sh. You can also use Nushell outside of Couchbase Shell as a shell if you want to. And they have a full book that you can go and read through, basically, if you're new to Nushell. Also a cookbook with recipes. So the cookbook contains examples, end-to-end examples, how to perform certain tasks in the system. And also on GitHub and Discord, the Nushell team is very active. Personally, I'm also in the Discord channel, and if you have questions, especially around the Couchbase commands, for example, very happy to help you there as well. So from the Nushell foundation, let's get one level above and talk about the Couchbase shell that sits on top of it. As I mentioned before, we wanted to build it better is included. So you can download it as a single binary. It extends Nushell. So what it does, it adds custom Couchbase commands on top of the whole Nushell array of commands and functionality. The binary name is CBSH, as you've seen in the demo. And in essence, what it does is it allows you to connect to one or more clusters, right? And then run commands that are useful for both developers and operators to fulfill their tasks. It has the same command structure as the built-in commands. So if you figured out how to use a Nushell with its help system and so forth, The Couchbase one works exactly the same. And you can run all the Couchbase commands standalone. So you can do, for example, doc get airport 1234, or you can do what Charlie showed you, that basically you have your input coming in from the stream, and then you use a Couchbase operator as part of your data pipeline, basically. So you can use it in both places. And because Nushell is written in Rust, Couchbase Shell is also written in Rust on top. So let's go through some of the arguments or some of the commands that we provide. And you've seen some of them already, but let's go through them briefly. So we have the clusters command, which on the one hand allows you to list all the clusters you're connected to, but you can also use the health subcommand that performs basic health checks, and we are continuously planning to add more health check commands. So it will be more useful over time, right? Do more health checks and give you more information about your system. Then you can use the buckets command to list all the buckets, the nodes command to list all the nodes. The ping command is very similar to the ping command that we have available in our SDKs, which allows you to actively ping all the nodes in the cluster and give you health information about them. Then you can use the users command to either list all the users in your cluster. You can use the users get command to list a specific user, or you can even create or replace any user with the upset command. So again, using the buckets command, you can see, so here we have one cluster called remote, which has 3 buckets, a memcached bucket, an ephemeral bucket, and the Couchbase bucket. It shows you the number of replicas, what's the quota, etc. And then lists you the node. And for example, when you type the nodes command, the first thing you'll see is this is a cluster where one node in the cluster has different services enabled than 2 others, right? So 2 clusters have indexing and query enabled, and one only has the KV service enabled. They have all the same version and so forth. This also allows you to, if you're managing a big fleet of clusters, right, with just a couple commands, for example, you can audit your whole cluster saying, give me all of the versions that I'm running in my clusters, and then you can filter them, or you can build a histogram of what versions am I running. Am I running on a version that is outdated, that is EOL, etc., right? All of this is at your fingertips. We have commands to manipulate or fetch documents. So this is the traditional key value API, right? So you can get a document, you can insert, replace, or upsert a document content, and you can also remove documents. In this example here, we are fetching a document. So we can call doc.get, and then the document ID, in this case, my user, which returns the document ID, the cache value, and the content. The content is nested because it might contain any data, but if you call --flatten, as Charlie showed you, it will move the content basically to the top level of the row and give you an easier, more consolidated view of what's in your document. Here is an example on how to store a document. So we have a file called user.json, which contains a name and an age column. And then we can open the JSON file. And in Charlie's demo, Charlie used the map command to transform the data into a different structure. Here in this case, we use a different command in Nushell called wrap, which allows us to wrap, basically it folds the content of the name and the age into the content column, right? So we end up with ID and content because we also insert the ID, right? So we wrap the content into the content column, and then we use the insert Nushell command to add another column to our data, right? So we add an ID column called my user. And so we end up with ID and content columns as we need for the upset command, and then we can store it. So you can see you can either use the map command, you can use wrap insert, you can use all of the commands in your data pipeline to build the structure, and then you use doc upsert to store the data. On the query side, there are different commands available, both with query, analytics, and search. On the query side, in addition to performing a nickel query, you can also use the query advisor. You can list the indexes that are defined on your cluster, and you can do the same thing for the analytics service. In addition, you can also list datasets and dataverses. And with search, you can perform search queries. We are also planning to add indexes for search, all the different ways you can search, etc. So this is all in progress. We are heavily working on extending the capabilities of the individual commands and adding new commands, also based on your feedback. So here we can see a Nushell query. And then the other command that you can see on the screen is the rename command, right? So you can rename columns. In this case, we select airport name, city, and country from our through our Nushell query, and then we rename airport name to name. We city and country basically stay the same. So city and country are renamed to the same name, but the airport name is renamed to name. We can list all the Nushell indexes that are part of our cluster. And you can see on the left side in the bucket column, you can see that certain indexes are for different buckets, right? So you could, for example, use the where command to say, give me all my indexes where bucket equals tilde default, right? And there are many more commands available. For example, version gives you the current version of Couchbase Shell. The whoami command runs a query against the cluster and gives you information about the current user, what the assigned roles are, and so forth. You can generate fake data. You can transform data with map. The use command allows you to switch clusters and show you what active cluster you're working on. And then we have advanced command like datastats, which gives you low-level access to the key value service datastats. Again, an advanced command, as well as the buckets config command, which gives you access to the low-level bucket config. Those commands are really useful if you are drilling into, like if you have an in-depth knowledge of Couchbase for our power users and you want to get to very specific statistics or bucket configuration properties that you want to look at. Here's an example of generating fake data. Fake always needs a template in the Terra format, but it is pretty much a very simple text format that has certain placeholders, and we provide examples in our repository. And when you download it, and you can generate all kinds of fake data. It doesn't matter how many data you want to generate. So you can generate megabytes or gigabytes of data and bulk load it into Couchbase. So next steps, call to action. What we really want from you is go to couchbase.sh, download the binaries. It doesn't matter if you're on Windows, Mac OS, or Linux. Give it a try. We have documentation available as well. Read through the docs, try it out, give us feedback, right? It's still, the project is of course usable, but it's still early. We really want to get your feedback, what works, what doesn't work, what you would like to see in Couchbase Shell as new commands, extended functionality. Let us know in the forums, let us know on the issue tracker on GitHub, and yeah, just help us make the experience even better. And yeah, enjoy Couchbase Shell, enjoy playing around with it.